Hello everyone. Today we will continue to look at the content of HC-Storage. After our previous explanations on the basic structure of solid-state drives, data writing, data reading, and a series of other topics, everyone should be quite familiar with the overall characteristics of solid-state drives by now, right? Having discussed so much, let's finally do a summary of our solid-state drives. The performance advantage, we can make a final summary. So first, in today's era of data explosion, the performance of our storage devices is actually very important. The main advantage of solid-state drives is actually their high speed. Nowadays, it has actually become the preferred storage solution for many enterprises, including individuals. For example, in many computers now, the default is actually solid-state drives. Secondly, in our servers, we can also use solid-state drives for certain tasks, such as, for instance, for businesses that have relatively high demands on speed, such as storage read and write speeds, many are now extensively using solid-state drives. The market for mechanical drives is becoming increasingly smaller. How should I put it? As time progresses, the development of this time, in fact, is the final one. Mechanical drives will, in a little more time, essentially be nearing their end. They are almost at the end of their life cycle because the main issue with them is speed. They are too slow and can no longer meet the demands of the current era. If you think about it, right, if it were 10 or 20 years ago, right, we would have, in a situation where the internet wasn't developing so quickly, it wouldn't have been a big deal, right? There wasn't much data on the internet back then. But now, as the internet develops faster and data grows larger, mechanical drives can indeed store a lot of data, but they can't keep up with the speed, right? If your storage speed can't keep up with the speed at which data is generated, that's a problem. This is one of its issues. The main performance advantage here is when compared to traditional mechanical drives, So first of all, the big issue with traditional mechanical drives is that they rely on mechanical components, which leads to their speed being greatly limited, because in this case, traditional ones like, in our disks, don't we have platters, right? When the read-write head is performing data read-write, it needs to find specific positions on the spinning disk, on the spinning platter. This results in what? It results in the first seek time, right? And secondly, mechanical delay time. So these times, actually, no matter how fast you are, right? No matter how good or fast your performance is, it still takes some time to find this content, right? To find your data. However, our solid-state drives actually have no mechanical parts, right? They are relatively more stable with no mechanical parts and are not afraid of vibrations. Secondly, when we are searching, we do it through a mapping table of logical addresses to physical addresses. So, when you need to find some content, I can just look it up in the table and know where it is, and once it's found, you can start reading it. It's much more convenient than using mechanical parts, right? Using a read-write head to search around the disk. So this is the first point. The second point is about response time, which is also a significant advantage. With traditional mechanical hard drives, a large portion of the time is wasted on seeking and mechanical delays. It's like you can think of it as, well, with a mechanical disk, it's like a worker in a warehouse searching for goods, without any efficient method, just searching hard, going through each shelf one by one to find the data. It needs to move back and forth between these shelves, which is equivalent to the seeking process. Moreover, the way the goods are arranged in the warehouse, well, it also limits the movement and speed. It also limits the action and the speed of action. It is equivalent to a mechanical structure problem, which also limits our mechanical delay, which will cause the efficiency of data transmission to be seriously restricted, even if you have this. No matter how large your storage space is, or how good your performance is. However, you can never completely avoid encountering issues, including mechanical delay problems. So this significantly affects scenarios that require very high speeds, making them completely unusable. Especially in cases like financial trading systems, for example. Every second of delay can potentially lead to huge losses. In such systems, it is absolutely unacceptable. You can use this traditional your mechanical hard drive. If you have a large number of transactions coming in simultaneously, what about your disk seek? It might frequently be seeking, And the mechanical components might also have some delays, which could lead to what? It could cause the system to display slowly, or it might even lead to transaction lags or failures. Ah, I see. As for our solid-state drive, first of all, it doesn't have any mechanical components inside, which eliminates seek time and mechanical delays. It's like this. Actually, this can be moved from the warehouse to the library, right? In the library, we have clear records of the location of each book, like which book is where, right? Which book is in which position. We can quickly locate the data we need, and it can respond to our read and write requests faster. In the same financial system, our solid-state drives can actually handle a large number of requests more quickly, ensuring smooth system operation and improving the efficiency and reliability of transactions. This is one of its characteristics. And this includes what? It includes read efficiency. Earlier, we mainly talked about writing, right? Reading is the same. With mechanical drives during read operations, the read-write head keeps spinning and moving continuously. This results in relatively low read-write efficiency because data storage in mechanical drives is arranged in a sequence based on physical location. When there is a need to randomly read data from different locations, it requires frequent repositioning. It's like constantly changing your route, which wastes a lot of time. For example, applications where random read-write is common include databases. In database applications, random read and write operations are frequently used. If using a mechanical drive, it will require frequent movement. Data queries, update operations, write operations, delete operations, etc. will be relatively slow. In database operations like adding, deleting, updating, and querying, these actions become slower, affecting the overall system performance. However, with solid-state drives, the internal controller calculates the data storage location and performs read-write operations, eliminating the search time and improving read-write efficiency. Inside the solid-state drive, it's essentially like an intelligent scheduling center, which helps us quickly locate the data storage position, and can handle multiple requests simultaneously, achieving parallel operations, especially in terms of reading. This is a major advantage in terms of read and write operations. Then regarding power consumption, first of all, in terms of power consumption. Here, in our image, there is a comparison chart that everyone can look at on the right side. Here, first of all, what are we basing this on? Based on, let me see, the unit is 100,000. Based on a power consumption comparison of 100,000 IOPs, this shows our now comparison under 100,000 IOPS and power consumption. Two solid-state drives can reach 100,000, whereas for mechanical drives, we need about 250 of them. And what about the power consumption? The power consumption is almost on the left side. 400 times that of solid-state drives. That is for the same read and write performance. The power consumption of solid-state drives is far lower than that of mechanical drives. This is a significant advantage here. First, its power consumption is relatively low. The power consumption is relatively low. Secondly, our read and write frequency is extremely fast. With the same power consumption, our read and write frequency is much greater with solid-state drives, far exceeding, that of mechanical drives. Or conversely, with the same read efficiency, the number of solid-state drives we need will be greatly reduced by more than 100 times, right? It's already more than 100 times different. And this is the difference in power consumption and read efficiency. Overall, solid-state drives rely on what? Short response times and high read-write efficiency, which provide a significant power consumption advantage in large-scale applications. In situations with a permanent large number of hard drives, solid-state drives save far more resources and electricity compared to mechanical drives. Simply put, they save a lot of electricity. In the field of storage, we have already demonstrated a very, very strong competitiveness, whether for enterprises or individuals. Solid-state drives are now actually the best choice, without exception, truly without exception. Because under normal circumstances, generally speaking, Mechanical drives don't actually have that much storage, right? For enterprises, cold data is just that much, and individuals don't really need any cold storage, so this is the overall performance advantage of solid-state drives. Okay, if anyone wants to learn about Huawei's cognitive technology or obtain Huawei certification question banks, please send me a private message or leave a comment below the video for technical exchanges. Alright, we'll stop here for today, everyone.